So we're going to start 1.1 midterm notes. Basically in this first section we're just going to highlight and write a couple notes. Remember the undefined terms, point, line, and plane. These are terms that we all agree what they mean, but there's really no way to define a point without probably saying the word point or a line. We all understand what those words mean, so therefore they're undefined. A point has no dimension, or a dot usually represents a point. If we were to name this, you can name it like point A, or you could just use a capital letter A. That's the most popular way to write it. A line has one dimension. It's represented by a line with two arrowheads. So these arrowheads represent that they go infinitely in both directions. And we could name this picture. You can name it a couple ways. You could say AB with arrows above. You could say BA with arrows above. Or you can use this lowercase letter and say line L. But those are the only three ways to name this line. Again, with either 2 points and the arrows above, or the word line and that lowercase letter. Alright, when naming a plane that's two-dimensional, it usually looks like this parallelogram, but really it's any two-dimensional shape, and you're supposed to imagine that it extends without end. It continues in many directions. You can name it a couple ways, but you always have to name it with the word plane. And then, I would take your pen and underline this, you can use any 3 points not on the same line. So, the only points in this picture are A, B, and C. None of them are on a line, so you could just say plane ABC, or CAB, BCA, yada yada. Or you can use the one letter off to the side. There's no dot at it, so this represents that it's actually the name of the plane. So you could say plane M. But again, you cannot use 3 points on the same line. So if, let's say I had a line that went through B and it had D and E, I could not name this plane B, D, E. Not an option. No combination of the letters B, D, and E. I could say B, D, A, D, E, E, D, C. Any combination of 3 of the points, except for the combination of the 3 on the line. So then there are type of lines. Again, you have a line here. Lines extend without any end. So that's the first one. The second one is a segment. The segment has a start and an end. These are called endpoints. So what you would do to name the line, you would use the 2 endpoints. A, B. You could also say BA. If there was a letter in between, like let's say there was a C here, to name the entire line, you would still say A, B, or BA. If you wanted to name part of the line, you could say AC, but again, that would only count from A to C. Array has a starting point, and then it goes infinitely in the opposite direction. So this first one, you have A, B. Every time that you name array, I just got interrupted, so sorry if I repeat myself. To name array, you use an arrow pointing to the right, and then your end point goes first. So the end point of this, or a starting point if you want to call it, would be A, and then it goes off infinitely towards B. For our second line, it still points to the right. You still put your end point first. So your end point is B, so you say B, and then it goes off in the direction of A. The last one are opposite rays. So 3 things happen when you have an opposite ray. They have, it's like a bullet point, they have the same end point. They are collinear. And they go in opposite directions. So, in order for you to have opposite rays in this picture, the endpoint they would have to share is C. So, you're going to have 2 rays, so I'm going to name them with the arrow pointing to the right. The end point for both of them will be C. If I wanted to name this left portion, I would say CA. If I wanted to name the right portion, it would be CB. And those would be opposite rays. Flipping to the next page, it says give 2 other names for line CD. Let's go ahead and highlight that. It'll be this line. Keep in mind the dot dots mean that the line goes behind the plane. So we could say CD. I know it looks a little weird, but these are arrows. They're teeny tiny. So another way to name CD very easily is DC with your arrows above. Or your other option, you could say the word line and then look for a lowercase letter on the line, which would be M. It's not a point, it's the name of the line. So those are 2 options. The next one, give another name for plane M. So again, you're wanting to name this plane. You can use, well, first you have to say plane. The reason that they used 1 letter is M is in the corner. It's not a point. It's the name of the plane. And then you're going to use any 3 points except for the 3 that are on the same line. So you could use these 3, you could use these 3, you could use, these 3, any 3 as long as it is not A, B, and C. So we could say plane A, C, E. And then again, you can't use D because it's not on the plane, and then M isn't even a point, and then neither is this M. So the only options were any of these 4 letters. Next question says name 3 points that are collinear. Collinear, if you don't remember, it is a vocab term on your midterm review. Collinear means points on the same line. So you want 3 points that are on the same line. The only options are A, C, and B. To name points, you use capital letters. You could say ACB, or you could say point A, point C, point B. Both are fine. The next part says the name a 4th point that is not collinear with 3 points, these 3 points. So you could say E, or you could say D. Both are fine. I'm just going to say E. But again, you could also say D. Number 4, name a point that is not coplanar with A, C, and E. Coplanar is also a vocab term. It means on the same plane. So you're looking for a point on the same plane, or not on the same plane, as A, C, and E. So you can't name, obviously, A, C, and E. B's on the plane. M is not a point. Neither is this M. So the only option is D. Number 5, what's another name for PQ? Again, there are a couple of options. The easiest one would be turning it around and saying QP. You could also say QT, because remember those arrows mean they go infinitely in both directions, past the letters P and T. There's no dot at T, but it's because 2 lines are crossing, and they're not going to put a dot there because it's a little chaotic. But you could say PT, which means, of course, you could say TP. You could say TQ, QT. The last option you could use is using the word line and then the lowercase letter above the line. Any of those are acceptable. And then the last one, what's another name for RS? Again, they're little lines. You can see it better on your page than mine. We're just going to say SR. But again, it could have as many options as the first. You could say SR, you could say RT, you could say TR, you could say TS, ST, or you could say line K. Any of those are options. We will move on to 1.2 notes. 1.2 is about congruent segments. So hopefully you remember this. Go ahead and highlight it if you don't, or just in general. This symbol right here means is congruent to. You can say the length is equal to length, or you could just say the segment is congruent to the other segment. So we would write it like this. Remember that if there's no line above, it means the length of. So again, if there's no line above, it means the length of that segment. So the length of AB equals the length of CD. Or you could say segment AB is congruent to segment CD. Both are acceptable. Let's see. And then the segment addition postulate. This one, a lot of you do very well with. If you take AB and add it to BC, that's the length of AC. Very easy example. We used at the beginning of the year. A football field is 100 yards. I'm not including the end zones, obviously. If LJ runs 80 yards, then how much remains? Well, if there was 100 total, and he ran 80 of them, 100 minus 80 would be 20. So this piece would have to be 20 yards. Okay, so we're going to use both these in solving some of our problems. We'll plot the points on the coordinate plane, then decide whether the segments are congruent. So, in order to plot points, you do need an x and y axis. So we're going to go and draw them. Those are your x and y axes. We'll plot some points. So keep in mind they were named A, B, and C, D. So these two will be connected, and then these two will be connected. So we're going to do negative 5, 5 first. So go backwards, 1, 2, 3, 4, 5, and then up, 1, 2, 3, 4, 5. This is point A. Then for B, go to left 1, 2, and then up 1, 2, 3, 4, 5. So let's say what the length is. Remember there's no line above, which means length of. So length of AB is 1, 2, 3 segments. We'll do the same thing for the next one, CD. C says we go over 2, 1, 2, 1, 2, and then down 1, oop, nope, it's terrible. 1, 2, 1, 2, 3, 4. So this is C. And then D will go to the left 1, and then down 1, 2, 3, 4. Connect the dots. So CD equals 1, 2, 3. The length is 3. So congruent means they're the same length, and they are. So we're going to say line segment AB is congruent to line segment CD, because it's asking if they are congruent in the directions. We'll do the same thing over here. We got A is 4, 0, so over 1, 2, 3, 4, up 0. So here's A. B, we have 4, 3, 1, 2, 3, 4, up 1, 2, 3. So let's see the length of AB. 1, 2, 3. We'll do the same thing for C and D. C is negative 4, negative 4. 1, 2, 3, 4. Down 1, 2, 3, 4. And then D is negative 4, 1. So 1, 2, 3, 4. Up 1. So the length of CD, 1, 2, 3, 4, 5. You could probably tell by the way that they looked. They are not congruent, so the way you would say this, I'll write up here, the length of AB is not congruent to, segment AB is not congruent to segment CD. And those would be your answers. We've got 3 and 4. It says find the length of VW. So we know the full length is 31. You already have 8 of the 31, so we are going to subtract in order to find the length of VW. So VW equals 23, because 23 plus 8 will give you 31. The same thing with number 4, we have the full length of 18. We have 6 of that 18, so to find what remains, we're going to subtract. So VW will equal 12. Last one, it says a bookstore and a movie theater are 6 kilometers apart along the same street. A florist is located between the bookstore and the theater on the same street. The florist is 2.5 kilometers from the theater. How far is the florist from the bookstore? So let's draw a picture. It says they're on the same street, so we're going to draw a street. It says a bookstore. We'll put the bookstore here. And a movie theater are 6 kilometers. So 6 kilometers apart. A florist is located between them. It's located 2.5 kilometers from the theater. So I'm going to estimate right here. It is 2.5 away from the movie theater. So then it says, how far is the florist from the bookstore? So again, here we would subtract 6 minus 2.5, which would be 3.5 kilometers. From here, we'll move on to 1.3, and then that's where we'll stop for the day, is 1.3. So let's find it. Here we are, 1.3. So this is where we talked about midpoints. The midpoint of a segment is the point that divides a segment into 2 congruent segments. So remember that these marks mean congruent. So if M is the midpoint, that means that AM is the same length as MB. So if AM is 7, that means MB would also be 7, so the full length would be 14, so that kind of thing. A segment bisector, go ahead and highlight this. A segment bisector is a point, ray, line or line segment, or plane that intersects the segment at its midpoint. A midpoint or segment bisector bisects the segment. Bisects is also a term on your midterm review and on your midterm. It basically means to cut something in half. So a lot of students didn't do very awesome with this. I'll show you why. Here are the different ways your segment bisector can look. Basically, what is in the middle of the picture? If it just looks like this, then the segment bisector would be a midpoint, and it'd be M. If it didn't look like that, if it looked like this, let's say MR. This is a ray, has a starting point, and then it goes infinitely in the other direction. The segment bisector would be MR. If it continued through the midpoint, it would be a line MR. So those are the options. You just need to look at the picture. If it's not a line or a segment or a ray, then the segment bisector is the midpoint. That should be your last option. If nothing is in the picture, then it's the midpoint. But if something, like in this one, is in the picture, a line of some sort, then that is the segment bisector. So here we would say CD is a segment bisector. Again, you can name it MD, DM, DC, what else are we missing? MC, CM, that kind of thing. That's your segment bisector. And then the midpoint formula, go ahead and highlight midpoint formula. This is how you find the middle. You're finding the averages between the x-coordinates and the y-coordinates. So the midpoint equals x1 plus x2 divided by 2, then y1 plus y2 divided by 2. So again, you're finding the average. That's why you add and then divide by 2. But this is the formula you use. The x's go in the first fraction, the y's go in the second fraction, and again, you need to add them. Those are the common mistakes with this formula. The distance, you're finding the distance. You could also see you're finding the length, which we'll talk about in a minute. But the distance equals, you'll have this long radical. you've got these parentheses, and then subtraction between the parentheses. I told you to remember the signs. It looks like a face. So minus, plus, and minus looks like a face to me, and you guys agreed at one point. So you do that, and then you're going to do x1 minus x2 and y1 minus y2. It's the same as y1 minus y2, and then x1 minus x2. Sorry, I realized after I said it this way, I believe the way you learned it was with y's first. But it doesn't matter because you're adding. So if this is the way we did it, then do it this way. But again, it's the same exact thing because you're going to subtract first. So if you don't remember how to solve this kind of problem, you subtract first. So either way it looks like. Subtract first, and then you square. Use the squares. And then after you do that, you add. So either formula that you use, it's the same exact thing. I believe we used this one, so I apologize. I'm going to use that on the next page. So let's go ahead and solve some problems. This one says identify the segment bisector of AB and then find. Again, when there's no line above, it means the length. This means length of AB. So identify the segment bisector. So the segment bisector is either the midpoint or a line that goes through the midpoint. I don't see a line. It would look like this or something like that. We don't have one. So the segment bisector is M. And then the length of AB, I believe it asked for, A to B. This line means that they're congruent. So you have from AM, which is 13, to MB, which is 13, add them together, you get 26. So AB, the length of AB, equals 26. Number 2, segment bisector is what cuts the line in half. It's not just a point this time. This is a ray. It has a starting point, and then it goes infinitely in another direction. Again, the reason it doesn't have a dot is because there are two lines intersecting. So you'd say MC. You cannot name it any other way besides MC because your endpoint needs to be named first. So MC is a segment bisector. And then AB, if this half is 8, then this half is also 8. 8 plus 8 is 16. And then the last one, segment bisector is a line. You cannot name it with arrows this time. When you name it with arrows, you need 2 points. The only point that we have is M. I don't have another point on the line. And L is not a point. So the only way to name this line is line L. And then the length of AB. If this piece is 26, this piece is also 26. 26 plus 26 is 52. Next one, find the endpoint, the endpoints are given. Find the coordinates of the midpoint, and then find PQ. Again, this means the length of PQ. So when it says something like that, when it says find the length of PQ, this means find the distance between P and Q, and that will give you the length. So we'll start with the midpoint. Use our formula, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So we're going to add our 2 x's first, which would be -4 and 0. I'll write an equal sign. -4 plus 0 is -4. -4 divided by 2 is -2. So that's our x of our midpoint. The y of our midpoint, we're going to add the 2 y's together. so 3 and 5. 3 plus 5 is 8. 8 divided by 2 is 4. So this is the midpoint. So we've answered the first part of the question. To answer the second part, we're going to use the distance formula. So here we're finding the length of PQ. So you'd write PQ. Oh my gosh, so sorry. Struggling. So again, you're going to, I believe we said we're going to do y1 minus y2, and the next one minus x2. Again, what matters is that the y's are together, the x's are together, they're being subtracted, and then the middle sign is a plus sign. So we're going to add the two y's first, subtract the two y's. So y1 is the first y, which would be 3, minus y2, which is 5. Then we'll plug in the x's. The first x is negative 4. The second x is 0. So from here, I told you the steps. We're going to subtract. So keep our radical, keep the squares. 3 minus 5 is negative 2. Minus 4 minus 0 is negative 4. And then we're going to square. So negative 2 squared is 4, because negative 2 times negative 2 is positive 4. Keep your plus sign. Negative 4 squared, which is negative 4 times negative 4 is positive 16. We're going to add them, which would be 20. Oh my gosh, stop it. Y'all, I'm struggling. It's Sunday afternoon here, just so you know. I'm here on the weekend. The square root of 20 is 4.5. 4.5. We're going to leave the second one for tomorrow. We will, however, do the bottom if you're in honors. If you are not in honors, this is where you will stop. But again, if you are in honors, these last two are in the exam. So, honors. Okay, so we're going to use the midpoint formula. If you remember doing this at the end or the beginning of the year, we use the midpoint formula because the midpoint and one endpoint are given. We're going to find the other endpoint. But in order to do this, we have to actually break apart the midpoint formula. So this part of the midpoint formula gives me the x of the midpoint, right? And then this part of the formula gives me the y of the midpoint. So the y of the midpoint. So we're going to plug in everything that we know, and then we use algebra and we solve. So I'm just going to make room for myself. Let's find the x of the midpoint, which is what's going to go here. X of the midpoint is 1. And then up here, you put the x of the endpoint that you're given. So the x of the endpoint we're given is 7. We don't know the other x, so we're going to put x. From here, we just solve. X is attached to the plus 7, so we need to get that by itself. They're currently being divided by 2. The opposite of that is multiplying by 2. 2 times 1 is 2. And then on the right side, you have 7 plus x. Subtract 7. And you have negative 5 equals x. So of our new endpoint, we have negative 5. We're going to do the same exact thing to find the endpoint, the y of the endpoint we're missing. So we're going to plug in the y of the midpoint, which is negative 2. plug in the y of the endpoint they gave me, which is 2, and then I don't know the other one. So again, y is being added by 2, so we need to get that by itself. So we're going to get rid of this denominator by multiplying on both sides. 2 times negative 2 is negative 4. And then on the right side, you still have 2 plus y. Subtract 2, negative 6 equals y. So of my new endpoint, keep in mind, the length, the segment was jk. We already have j, so this is technically k. K equals negative 5, negative 6. We will do it again, one more time, right next to it. Same formula. So you're going to take the x to the midpoint. Just going to move this over. Equals x1 plus x2 divided by 2. Do the same thing for the y of the midpoint. Again, m will represent the midpoint. So keep that in mind. So we're going to plug in the x in the midpoint, which is 0. That'll make life a little bit easy. The x of the endpoint they gave us is 5. We don't know the other one, so we're going to put x. We'll do the same steps. We want to get rid of this denominator, so we're going to multiply both sides by 2. 2 times 0 is 0. One last step to get x by itself. Subtract 5. X equals negative 5. Do the same thing for y. The y of the midpoint is negative 1. The y of the endpoint they gave me is negative 2. Multiply both sides by 2. 2 times negative 1 is negative 2, which equals negative 2 plus y. Add 2. So we have y on the right side. Minus 2 plus 2 is 0. So negative 5, 0 is your other endpoint. This concludes our review for 1.3 and 1.2 and 1.1.